Alright, for graphing piecewise functions, tells you graph f of x. And here, this bracket or set notation is kind of telling you you have 1, 2 pieces. Okay? It's separated by the if, so it kind of gives you a restriction to look at. And our steps are, we're just going to graph these. Definitely recommend graphing it in pencil. And then we're going to erase it. Okay, we're going to erase certain parts it tells us not to. Okay? So let's go ahead and try that. The first one is x plus 2 if x is less than or equal to 1. So here you have, pretend this part up here kind of reads y equals x plus 2. And basically that's a linear in slope-intercept form. So pretend it's like y equals mx plus b. Does that make sense? So here my starting point is 2. So let's go find my y-intercept of 2. And my slope here is 1. So my slope here is really 1 over 1. Kind of hard to see. So basically that's my rise of 1, run of 1. 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 Remember, if it's a positive 1, you can also do down 1, left 1. Down 1, left 1. Negative 1 over negative 1 is positive 1. And that means my graph going left to right is positive, right? So if you're going on a roller coaster, it's going up. So let's go ahead and graph that with a pencil so you can erase it. Alright, let's start at this now, our restrictions. If x is less than or equal to 1, okay? If you put your pencil at 1, where x is 1, there's this line here, okay? Now, it's not an asymptote, okay? It's like a fake boundary. Everyone say fake boundary. Right? My daughter Eloise runs everywhere, and I have to tell her, right? Like, don't run to the parking lot, right? There's really no line, but it's just like, don't run here. So I'm just going to give you this fake boundary, a visual, just so you can see what's happening, okay? Put your finger on the side where it says less than 1. Which side is less than 1? Well, these numbers are what? Bigger than 1, and these numbers are less than 1. So we want this side of the graph. So I'm going to erase all of this part. Okay, so get a good eraser. Erase it. Alright, I picked pink. Let's graph this one in pink. Okay? So basically my graph is here. And when I'm touching this restriction or this boundary here, it's equals to. So class, is that going to be an open or closed circle? Closed circle. So make it that obvious that it's a closed circle. Okay? Let's graph the second one now. The second one says f of x equals 4. It's kind of weird for us, right? F of x equals 4. What does that mean? What's another way of writing f of x? The y values are 4. I never liked horizontal and verticals. So for myself, I always make a table of values. What are all the y values? What does it tell you? They're all 4. And then you make up some x values. Does that make sense? Someone make up some numbers. 1, 2, 3. Let's graph it. Graph with pencil. 1, 4. Right 1, up 4. Right 2, up 4. Right 3, up 4. So my pencil is going to look like this. My graph is going to look like this. So it is a horizontal line where all the y values are 4. Now, it tells you a restriction. It tells you if x is greater than 1. Well, there's the 1 I was looking for. It just so happens in this piecewise function, it's the same number. Do you guys see it? Now, put your finger on the side where x is greater than 1. 2 is bigger than 1. 10 is greater than 1. So we want this side. Yes?
Yes.
So we're going to erase everything to the left of the blue line. I'm erasing everything to the left of the blue line because these are less than 1. This one's greater than 1. So everything to the left or less than x, I'm erasing. Pick your favorite color. I'm going to do mine in green. Here, this is greater than, so class, is that an open or closed circle?
Open.
And then we're going towards the right. So class, is that blue line normally there? No. It's just kind of helping us see those boundaries. It'd be nice if it was only just the pink and the green lines, but here is a basic piecewise function.